Welcome to Homework Lib.
In this problem, we have a contraption here. We have 3 weights hanging from 1, 2, 3, 4, 5 pulleys. We have 2 cables. And so the constraint for this first cable here is this span here is YA plus a constant. This span here is YB plus a constant. And this span here is YB minus YD plus a constant. This is what the position of this pulley here, which is floating. It's not attached to ground or to any of these other weights. I'll call it has position YD. Y is positive down. So we get YA plus 2YB minus YD is a constant. And then for this cable here, we have this span here is YD plus a constant. This span here is YD plus a constant. This one here is YC plus a constant. And this is YC plus a constant. So we get 2YD plus 2YC equals a constant. We could divide through by 2 and get YD plus YC as a constant there. Taking time derivatives, we get VA plus 2VB minus VD is 0. We get acceleration of A plus 2 times acceleration of B minus acceleration of D is 0. And from here we get the velocity of D plus the velocity of C is 0, and the acceleration of D and the acceleration of C is 0. Plus the acceleration of D plus the acceleration of C is 0. Now we're told that A here starts from rest and has a constant acceleration of 6 inches per second squared. So if it starts from rest, it has an initial velocity of 0. So we can use this equation here at t equals 0. And since VA at 0 is 0, we get that VD at 0 is twice VB at 0. So the initial velocity of VD is twice the initial velocity of VB. And now we're told that VB has a constant velocity that is minus 3 inches per second. So that means its initial velocity is also minus 3 inches per second. So the initial velocity of D is minus 6 inches per second. So that was this pulley here. So this pulley is moving up 6 inches per second. And then from here, if we take at t equals 0, we have VD0 plus VC0 is 0. So that means that VC, its initial velocity is 6 inches per second down from this equation, substituting this into there. Now, we're asked, we want to know at what time does the velocity of this pulley equal 0. So I'll call that VC1. So velocity of C at time 1. And we don't know what time 1 is, but we know the velocity is 0. That means from here that VD at time 1 must be 0. And up here we know that VA plus 2VB at time 1 has to be equal to 0. We know VB at time 1 is the velocity that it always is, minus 3 inches per second. So we know we wind up with VA is 6 inches per second. So VA1 is 6 inches per second. So that's at time at T1. So then we can go. We know that this weight here started at rest and has a constant acceleration, and so we can then its velocity at T1 is the acceleration times T1. And so we know what's velocity and we know what's acceleration, and we just get that T1 is 1 second. So after 1 second, the velocity of this pulley, this weight, is 0. And then we want to know what the position of this weight is at that time. So its position is 1/2 times its acceleration times T1 squared. So its position at T1, and it's plus its initial velocity times T1. Now its acceleration, we know from So we know a sub c, um, we know we can get that from these two equations. So a sub c is minus a sub d, and a sub d is a sub a. So a sub c is minus a sub a. So the acceleration of this pulley is minus the acceleration of that pulley at all times. And then we have, we need the initial velocity of this pulley here. So we can get that from the initial velocity here. We got that from, if we have Vd, we know that Vd of 0 is minus 6 inches per second, because from this relationship, from the velocity at t equals 0, from the velocity constraint at t equals 0 for the first cable, and that gives us Vc, and velocity constraint for the second cable tells us that Vc naught, the initial velocity of this weight, is 6 inches per second. So 6 inches per second down. So we know everything in here now. So this is 6 inches per second squared. This is 1 second here, and this is 6 inches per second. And so we plug everything in, and we get that this block has moved down 3 inches before it starts to move back up again. So initial velocity is negative, or is positive, 6 inches per second, and then it goes down to 3 inches, and then the velocity changes sign, or the displacement changes sign, and the velocity is 0, and the velocity changes sign, and now we're moving upwards after that.